topics discussed in this presentation will be IP protocol and its format IPv4 header and IP fragmentation. IP protocol is an unreliable protocol because the data transmitted will not be acknowledged back to the source. So IP protocol is an unreliable protocol, and reliability will be achieved by using the acknowledgement mechanism. Like TCP protocol, TCP is a reliable protocol. Whenever a segment is transmitted, it will be acknowledged back to the source. Whereas IP protocol is an unreliable protocol. The IP packet, whatever transmitted, will not be acknowledged back to the source. IP is a connectionless protocol. So whatever packet transmitted using IP protocol will be handled individually and independently. Before sending any data transmission, there will be no connection establishment process in the IP protocol. IP provides best effort delivery service. So whatever packet is transmitted will be transmitted in the right direction, and sometimes it may not reach the destination. So there is no throughput guarantee and no delay guarantee in the IP protocol. So the consequence is this part is handed over to the upper layer protocol like TCP. So whenever a packet is not reaching destination, by using the TCP protocol, by using acknowledgement mechanism, this problem will be rectified. And the IP packet may deliver out of sequence. By using the TCP protocol rearranging method, this problem can be resolved. IP protocol is a network layer protocol, and some of the alternate protocol in the IP layer is supporting protocols are ICMP and IGMP. So IP is not providing error control. So ICMP protocol is an add-on protocol or supporting protocol for the IP protocol. IGMP protocol is Internet Group Management Protocol. This protocol is used to take care of group management. IP is the waist of the hourglass of the Internet Protocol architecture. So whereas there will be multiple higher layer protocols and there will be multiple lower layer protocols, but IP is the only protocol at the network layer level. IP is the higher layer protocol which is implemented at both the routers and the host. IP supports the following services like one-to-one communication, which is called as unicast, and it also supports one-to-all communication using broadcast mechanism, and IP supports multicasting services which is one to several. Now we are going to see about the IPv4 datagram format. IP datagram is a variable length packet which consists of two parts. One is header and another one is data. The header part will be ranging from 22 to 60 bytes and contains information which will be required for routing and delivery of IP packet. This is the IP datagram header format. The header size is 20 bytes and total size of the IP datagram is 65,535 bytes. The first field is version field. The version field will define whether the particular IP datagram belongs to IPv4 or IPv6. The second field is header length field, which will define the length of the IP header. The third field is service type. So this service type defines the types of service. So it contains two parts. One is differentiated services and another one is explicit congestion notification. So this differentiated services is for providing quality of service. So quality of service means giving priority of the IP packet, whether it's based upon test communication or it's an audio communication, or it's a video communication, or it's a live streaming. So based upon that, quality of service will be decided. So this will define the priority of the IP packet. And it's just explicit congestion notification. So this is for notifying the congestion to the other end. Total length will define the total length of the IP datagram. And next field is identification field. Identification field is to uniquely identify a particular datagram. Flags field will define whether don't fragment or more fragment. So this identification flags and fragmentation offset field, these fields are used for fragmentation purpose. So if in case there is a need for a fragmentation, then the more fragment will be enabled. If the particular IP packet is not allowed to do fragmentation, then don't fragment bit will be set. So fragmenting is dividing an IP packet into multiple smaller size fragments. And then fragmentation offset. So this fragmentation topic will be seeing in the upcoming slides. Time to live field is to define a particular IP packet can be live state. So when the time is over, that particular IP packet will be removed from the network. So when the value comes to 0, the particular IP packet will be discarded from the network. So this prevents the routing loop. If this field is not there, then the packet will be looping across the network, goes to multiple routers, and will not be discarded from the network. So this purpose of this time delay field to avoid the routing loops. So for example, each router will decrement the value. So when the value reaches 0, a particular IP datagram will be dropped from the network. Next field is protocol field. So protocol field will define what particular upper layer data content is present in that particular IP packet. For example, the upper layer can be a TCP protocols data content, or it can be a UDP protocol data content. So what particular upper layer protocol content is that particular IP data belongs to. Next is header checksum. So it's a 16-bit long checksum is computed for any error happens during the transmission. Then this checksum will check it, and if there is any other values changes, then that particular IP is facing error problem and will be discarded from the network. Source IP address is the sending system's IP address. Destination IP address is the particular system is going to reach. Option. Record route option. In record route option, each router will process the packet and will add its IP address to the header. In timestamp option, each router will process the packet and adds its IP address, and with that it adds the time to the header. Source route option. Source route and strict source routing on slight difference. In loose source routing, the router routing paths will be predefined, and if there is any better path is available via the routing process, then it's allowed to deviate. That's what it's called as loose source routing. In strict source routing, there will be deviation is not allowed. So whatever path is predefined, only via that particular path, the packets are allowed to travel towards the destination. Padding field. So in case padding is secured, then additional data bits will be added, which is of 4-byte bound. Maximum transmission unit. The maximum size for an IP datagram is 65,535. But in case the IP packet need to travel via an Ethernet based network, in that case Ethernet having a maximum transmission unit size of 1,500 bytes. In that case, then IP packet need to be fragmented or divided into smaller bytes, which should be less than 1,500 bytes, so that it can allow to travel via an Ethernet based network. Same like there are multiple data link layer protocols where the size is different from one another. A02.3 is having a size of empty is 1492. A02.5 is 4464 bytes. So like that, every data link layer having different maximum transmission unit. So based upon the maximum MTU value, the IP packet need to be fragmented. So what is an IP fragmentation? So IP datagram is fragmented to smaller units so that it will be allowed to travel via that particular network protocol. So here in this example, FDDI is having a maximum size of 4352. So in that case, an IP packet need to be fragmented, which should be less than 4352. And same with an Ethernet based network, it should be fragmented less than 1500 bytes. So IP router will split the datagram into several smaller datagrams so that it can travel via that particular data link layer protocol. So fragmentation is done at the sender or it can be done at the intermediate side uh, by a router. The same datagram can be fragmented several times. The reassembly of the original datagram is done at the destination host. In this diagram, an IP datagram is fragmented to multiple fragments like fragment 1 and fragment 2. The different fields which is related to the fragmentation is one is identification and another one is flag field which is don't fragment and more fragment, and then fragmentation offset and then total length. So identification field will tell is to uniquely identify a particular IP or fragmented packet in an IP datagram, and flags will define whether more fragment, that is in case a fragmentation need to be done in an IP packet, whether further fragmentation is allowed or not. So don't fragment means the fragmentation is not allowed, so that packet will be discarded in case of fragmentation is required. And most fragment is if it's enabled, this flag field is enabled, then that particular IP datagram can be further fragmented. So fragmentation offset is for offset of the payload of the current datagram in the original datagram. So this is used to identify the location of the particular fragment in the original IP datagram. And total length is to define the total length of the current fragment. So we are going to see an example of IP fragmentation. So consider a datagram with size 2400 bytes, which must be fragmented according to a maximum transmission unit limit of 1000 bytes. So here the MT value is 1000 bytes and the datagram size is 2400 bytes. So this will be divided by 1000, and for that the header length need to be allocated, which is of 20. So it will be calculated by subtracting the 20 with the 1000. So 1000 minus 20 is 980 bytes. And also this according to the fragmentation offset, so this should be divisible by 8 bytes. So 980 is not divisible by 8. So the larger value, but it should be less than the 980, will be the fragmentation offset value. So here 976 is the value which is divisible, is the largest smaller number than 980. So this 976 is divisible by the 8. So here total length, so 976 plus 20 is 996 will be the total length. And the first offset, fragmentation offset will be 0. In the second fragment, the value of the fragmentation offset is 122. So this will be calculated based upon 976 divided by 8, which is equal to 122. And the don't fragment flag is set is here as 0. More fragment is set, then it means there is a upcoming fragment is coming. And then here in the that fragment, you can see that the fragmentation offset is calculated based upon 1952 divided by 8. So 976 plus 976, and then which is divided by 8 is 244. So that's what you can see, that the fragmentation offset value is 244. Likewise, the total 2400 bytes is fragmented into 3 fragments. Now it is allowed to transmit it in a network which is of MT of 1000 bytes. Thank you.